What's up, Tumnad lectures? In this video, we are looking at what we call bile synthesis, but we are mainly focusing on what we call bile acid synthesis, which is a very much great component of what we call the bile. If you find it helpful at the end of it all, please make sure you like the video, comment down in the comment section, and subscribe. Let's go ahead and get started. So now when we're looking at what we call the bile acid, it's going to be one of the major components of what we call bile. We talked about other kind of the components like the bilirubin, the cholesterol, the glutathione, the immunoglobulin A, the electrolytes, and even other kind of the ions being component of what we call the bile. Now in today's video, we are focusing mainly on bile acids, bile salts. These are going to be the main component of bile that aids in emulsification of fats. Besides that, they're also going to be aiding in absorption of what we call fat-soluble vitamins like A, D, E, and K. Okay, so now we are seeing that these bile salts are aiding in emulsification of fats and even also absorption of fat-soluble vitamins. So now let's go ahead and see how do we synthesize what we call the bile acids, bile salts. Okay. Now we need to first understand what is that substance that is going to be giving us, or from which substance do we manufacture what we call the bile acids. The primary classic example where we are going to be getting what we call the bile acids is going to be what we call the cholesterol. Okay, it's going to be what we call the cholesterol. So now we are going to be making what we call the bile acids from what we call cholesterol. So now, what is going to be the source of what we call cholesterol in our bodies? Now, we are going to be having cholesterol coming from what we call, we have some cholesterol coming from what we call diet. Okay, we can get cholesterol from diet, that is the foods we eat. Or even we can also get cholesterol from endogenous, because the body also can make cholesterol, like the liver can make cholesterol. Okay, so now it can make cholesterol from what we call acetyl-CoA. Okay, it can make from what we call acetyl-CoA, and even also what we call chylomicrons. Okay, what we call chylomicrons. Okay, so now these are going to be the main sources of what we call the cholesterol, from where we are going to be getting what we call the bile acids. So now we need to first understand within the liver, we have what we call a family of enzymes which does the breakdown of what we call cholesterol, the toxins, the drugs into their own other kind of the substance. This family of enzyme is what we call the cytochrome, is what we call the cytochrome P450 family. Okay, so now this kind of family of enzymes is going to be in the liver and it's going to be catalyzing metabolism of different processes within the liver. On that way, we are going to be having some of the enzymes that are part of cytochrome P450 family that are going to be breaking down this kind of the cholesterol into what we call the bile acids. So now, what are those enzymes that are going to be breaking down this kind of the cholesterol? Now, these enzymes are going to be breaking this kind of the cholesterol into two main components. So now, what are these kind of the components? Now, these components is going to be what we call deoxycholic acid. Okay, so now this one is going to be one of the classic examples of what we call the primary bile acids. And even also we are going to be having what we call the cholic acid. Okay, so now these are the two primary bile acids that are going to be coming from what we call the cholesterol after being acted on by these enzymes. You know how these enzymes are called? These enzymes, we have a first one which is called cholesterol 7-alpha hydroxylase. Okay, hydroxylase. Okay, so now this one is one of the most important enzyme part of the cytochrome P450 family, which is going to be a rate limiting enzyme. Okay, Why do I mean by that? When we say that it is a rate-limiting enzyme, it means that if you have too much of the cholesterol, this enzyme gets so much activated to break cholesterol into what we call these bile acids, okay? And even also when there's too much of these bile acids, they can exert an inhibitory effect to this enzyme such that we do not make more of them, okay? So that's why rate-limiting process. So it's going to be characterized by what we call 7-alpha hydroxylase enzyme. When we have too much of the bile acids, it will inhibit this enzyme from converting cholesterol into these kind of the acids. And even also when we have too much of the cholesterol, it will stimulate this enzyme to break the cholesterol into these bile acids. That's what we mean by rate limiting enzyme, rate limiting process, okay? Besides that, we also have another kind of the enzyme which we call the sterol 12-alpha hydroxylase, okay? Hydroxylase. So now this one here, you may even write it like in this way, okay? You may write it like CYP8B1, and then this one 7-alpha hydroxylase, you can even write it as CYP7A1, okay? So now these are other names. You can write this kind of the enzyme 7YP7A1 as that is cytochrome P7A1, and then this one for what we call the CYP8B1 for sterol 12-alpha hydroxylase enzyme. These are the enzymes that are going to be working hand in hand to make these primary bile acids. So now these ones here are going to be what we call the primary bile acids. Okay, they are the primary bile acids. Now, what happens that these primary bile acids, they are now going to be flowing down and they enter into what we call the biliary system, okay? These kind of the bile acids, they are now going to be moving, and then they now access what we call the biliary system, and then they go and get stored into what we call the gallbladder, until when we have a meal that is rich in fats, that's when they can come out and they enter into what we call the intestines. And then we're also going to be seeing what's going to be happening whenever this kind of the bile salts or this bile acid, when they run into what we call the intestines. However, this kind of the primary bile acids, they are not so much friendly with water, okay? So now the liver, what it does, it has those ability of conjugating these primary acids into a water-friendly kind of what we call bile acids, okay? So now what the liver does is that this kind of the channel deoxycholic acid, the liver adds what we call protein like glycine, okay, protein like glycine, and even also what we call the taurine, okay? So now even also can also add here what we call the glycine, okay, the glycine, and even also what we call the taurine. So now when the liver reacts this kind of the amino acids with these primary acids, we are going to be forming now the conjugated primary bile acids, okay? So now if you conjugate it, for example, with glycine, we are going to be making what we call glycol. We are going to be making what we call glycocheno deoxycholic acid, okay? So now for the case of now cholic acid, you are going to be getting what we call making what we call glycocholic acid, okay? So now these are going to be now the conjugated form of what we call the primary acid. So now if you conjugate it now with the taurine, you are going to be getting something like that taurocheno deoxycholic acid, okay? And then for the case of the cholic acid here conjugated by taurine, we shall get what we taurocolic acid. Okay, so now some of the primary bile acids moved down here. Some of them, a little bit of them, they ended up going into a conjugation process such that they become more water friendly for easy excretion as bile. Okay, now let's go ahead and see when these primary bile acids comes to the what we call the gallbladder, they get concentrated, and maybe you eat a fatty meal and they come and land inside what we call the intestines via what we call the sphincter of Oddi. What is going to be happening on what we call this kind of the primary bile acids? Now, these primary bile acids are going to be entering now, like this one here, this portion of the intestine. This one here is going to be what we call the duodenum. Okay, it's going to be what we call the duodenum. Okay, and then we're going to be having what we call like is here like the jejunum. Okay, like the jejunum. And then this one last year we are going to be having what we call the ileum. Okay, we're going to be having what we call the ileum, the terminal portion. Okay, so now we are going to be having this kind of the primary bile acids being broken down by what we call enzymes being produced by what we call the microbiota or intestinal kind of the bacteria. So now we have what we call the channel, deoxycholic cholic acid, and even also what we call the cholic acid. So now these are the kind of the primary bile acids that are now moving within the intestines. So now when they come in contact and they are broken down by what we call the enzymes produced by microbiota, you know how these enzymes are called? These enzymes that are going to be breaking down this kind of primary bile acids is what we call 7-alpha dehydroxylase. Okay, is what we call 7-alpha dehydroxylase, meaning that it is going to be removing what we call the hydroxyl group. Okay, now once this kind of the enzyme breaks down this kind of the primary bile acids, we are going to be forming the following. The channel deoxycholic acid is going to be turning into what we call the lithocholic acid. Okay, the lithocholic acid, and then the cholic acid is going to be converted into what we call deoxycholic acid. Now, the lithocholic acid and deoxycholic acid, these ones here are what we call the secondary bile acids. Okay, so now these ones here are going to be what we call the secondary bile acids. Okay, so now they are what we call the secondary bile acids. Now, what happened is that approximately 95% of these secondary bile acids are going to be absorbed back to what we call the liver. Okay, so now they are going to be absorbed by what we call the enterocytes through what we call the superior mesenteric vein. It will absorb all, especially on the terminal ileum, and is taken back to this kind of great vessel. You know how this great vessel is called? The one which enters the liver with having all kind of the substances absorbed in the intestine. This one here is what we call the portal. This one here is what we call the portal. Vein. Okay, so now 95% of the secondary bile acids are now going to be taken back to the liver. So now, for example, now these are going to be now they are going to be now moving to the liver. So now these are going to be now the secondary bile acids, the lithocholic acid, and even also the deoxycholic acid. Now, when they reach into the liver, the liver also does a process of conjugation. Okay, so now the secondary bile acids are going now to be conjugated, and then finally they will move to the storage center in what you call the gallbladder for storage. And then of course the 5% of what we call the secondary bile acids is going to be now getting eliminated with what we call the stool. Okay, now All these processes which we just talked about, they were happening in one of the most important structure within the hepatocytes, which we call the smooth endoplasmic reticulum. Why? Because you're going to be having tons and tons of these enzymes residing in what we call the smooth endoplasmic reticulum. So now, all these processes or breakdown of cholesterol into these primary bile acids is taking place into what we call the smooth endoplasmic reticulum. Okay, it is such another beautiful thing. So now, let's have a look a bit at what we call the clinical correlation with what we call the cholesterol. Sometimes we may have a patient who has high levels of cholesterol. So now, how do we combat or how do we manage some patients with what we call the elevated levels of cholesterol? How can we reduce the cholesterol levels in what we call the blood? So now, if you get a drug that blocks the absorption of what you call the secondary bile acids, okay? If you get a drug that blocks, okay? If you get a drug that blocks the lithocolic acid and the oxalic acid from getting absorbed back into the liver, this will make the liver to realize that there's going to be, it will make the liver to realize that there is low levels of what you call the bile acids. And in that way, the liver will break more of what we call the cholesterol into what we call the primary bile acids. By doing that, it is reducing the levels of cholesterol, okay? So now, these drugs that blocks the reuptake or the reabsorption of the secondary bile acids are going to be helping in reducing what we call cholesterol by increasing the breakdown of cholesterol into bile acids by what we call the liver. So now, those drugs are what we call, we have such kind of, those drugs are what we call the cholestyramine. Okay, cholestyramine. They block the reabsorption of secondary bile acids, making the liver realize that there is low bile acids, increasing the breakdown of cholesterol into what we call the bile acids. Such a beautiful thing, okay? Then also, we also have some other of the drugs. These drugs can block the enterocytes from absorbing what we call cholesterol, because we said we have some kind of the cholesterol which we can get from that. So now, if you get a drug that blocks the direct absorption of cholesterol from the intestines, you will be also reducing the levels of cholesterol in blood. Super very important and beautiful, okay? Then also, we also have some other kind of the drugs that are going to be blocking. They are going to be blocking what we call some of the different processes, especially the rate limiting process in the synthesis of what we call cholesterol. Okay. Now, these drugs, they target a specific type of enzyme, which is a rate limiting enzyme in the process of cholesterol synthesis. You know how this enzyme is called? This enzyme is what we call hydroxymethyl glutaryl coenzyme A, okay, reductase. Okay, reductase. So now, this enzyme, if you get a drug that blocks this enzyme, you are blocking the synthesis of what we call cholesterol, because this enzyme catalyzes a rate limiting step in synthesis of what we call cholesterol. So now, these drugs that blocks this kind of the enzyme, they are categorized under drugs which we call the statins. Okay, they are categorized under drugs which we call the statins. Okay. So now, and of course, these drugs which we are calling the cholestyramine, they are categorized under drugs which we are calling the bile acid sequestrants. Okay, the bile acid sequestrants, blocking the reabsorption of the secondary bile acids back to the liver. Okay, it's also such another beautiful thing. Okay, so now this briefly covers the synthesis of what we call bile acids, bile salts. So now, if you think whatever I've talked is making sense, is adding to you, you are benefiting, please, you can support me. And that one can be done by a couple of means. You like the video, comment down in the comment section, and subscribe. Thank you very much for watching. It has been Tumnad, as always. Until we meet next time.